or this one is on uniform motion problems of the form. Okay. All that to say is word problems that are talking about distance, but I'm going to kind of teach you something different today. Okay, so on these problems, it would probably be a good idea to realize, remember how last time I said distance equals rate times time. Okay, so I'm going to kind of give you a method to follow, and this can even be followed, I just thought of it, so this can even be followed on the previous ones you've done. Okay, is you always want to come up with an equation about the distance, about the time, and about the rate. And I did time and rate because sometimes it's easier to discover this than this. Okay? So let's come up with the equations for this. Okay? So let's read the problem, and we're going to try to come up with some equations about distance. We're going to read the problem and try to come up with some equations about time. And then we're going to read the problem and try to come up with equations about the rate. Okay? And sometimes you may not get anything from one of them, and that's okay. But that's how I kind of wanted to break it up this time. Okay, so here's what it says. A southbound bus left Fort Walton Beach at 9 a.m. Okay, so a southbound bus. So here's the bus going south. Okay, and I'm just going to go and draw it. It's headed toward Fort Walton Beach, and it left at 9 a.m. So I'm going to put 9 a.m. is when it left. Okay, 2 hours later, a northbound bus left the same station. So this is our station. A northbound bus left the station. And what time was it at? 2 hours later. So we know it was at 11 a.m. Okay? 2 hours later, a northbound bus left the same station. If the buses traveled at the same rate, I'm just going to write same rate. That's important to know. And they were 352 kilometers apart. I'm just going to write this information down. 352 kilometers apart at 2 p.m. Okay? Then find the rate of the buses. So we want to find the rate. Okay. I just wrote down key information. All right? And so this one left at 9 a.m. and then apparently it goes to 2 p.m. And then apparently this goes to 2 p.m. because they were 352 kilometers apart at 2 p.m. 11 a.m. to 2 p.m., 9 a.m. to 2 p.m., they were 352 apart. Do you get what I'm doing? Mm-hmm. Okay, now, so let's come up with our distance. Did they travel the same distance?
Yes.
Yes. So, what they want us to figure out, well, we don't know exactly the amount of distance, but we know the distance, I'm going to name this one that left it the southbound. The distance of the southbound was from here to here, right?
Yes.
The distance of the northbound was from here to here, right? Mm-hmm. So, it's fair to say the distance of the southbound plus the distance of the northbound equals 352. See how I came up with that one?
Yes.
Okay, now, because we've been learning about distance, and distance equals this times this, guess what I'm going to do? Let's say the distance of the southbound equals the rate of the southbound times the time of the southbound. Remember that?
Yes.
Now, when you see this ds, look what I'm going to write in it. ds equals rate times time. Distance equals rate times time. So let's go and change this to say that. So distance of s equals rate, the rate of the southbound times the time of the southbound, plus, and now let's change this from being southbound to northbound, the distance of the northbound equals the rate of the northbound times the time of the northbound. You see what I've done?
Yes.
Equals 352. So all I did is took what distance was and put it into our normal equation that we've kind of been coming up with all along. Mm-hmm. Okay, so now let's talk about time. Did we get anything about time on here? No. Well, 9 a.m. to 2 p.m. is what, 5 hours? 1, 2, 5 hours. So we know that since we're doing time, the time of the S is the southbound. The time of the southbound was 5 hours. Okay? The time of the northbound was from 11 to 2, so that's 3 hours. See what I've done so far?
Yes.
So it's good that we're coming up with categories. I got my distance categories, I got my time categories. Now let's do our rate. Didn't tell us anything about the rate. Well, we note that the rates are the same. So I'm going to say the rate of the southbound equals the rate of the northbound. Okay? And now this is good because I've come up with pretty much 5 equations, but we're going to use this one instead. So we've got this equation plus this plus this plus this. Okay, so these are my equations 1, 2, 3, and 4. So now we're going to take this main equation and insert everything into it. Okay. Got it? So here we go. I'm going to bring it down here. RS times TS plus RN minus TN equals 352. Just rewrote that. Alright, now let's insert stuff in. Alright, TS. Do I know TS? Yes, I do. It's 5. And it's times that. Okay? Do I know RS? RS equals RN. So I'm going to change this to RN. Okay? And then I'm going to want to keep RN right here instead of changing RN to RS, because then I've got 2 different equations again. I want to try to get RN or RS. Okay? And then do I know TN? Yes, TN is 3. Okay, so now I'm going to multiply this. This says 5 times RN, so I'm going to make it 5RN, plus 3RN equals 352. And it basically becomes a problem that we're used to. Since this is RN and RN, which is what we like, we can get same, they're same, so it's like 5 dogs plus 3 dogs, which would be 8 dogs, so 8 going northbound equals 352. And then, since this says 8 times RN, this times 8, when you bring it across the equal, becomes divided by 8, and then 352 divided by 8 is 44. So, 44 what? Well, we're doing the rate, and we know that it was kilometers, so the rate is it's either miles per hour rate is an equation like, not an equation, but a unit multiplier like miles per hour or kilometers per hour. Everybody in the world uses kilometers per hour. In America, we use miles per hour. Mm-hmm. So the rate of the northbound bus is going this fast. Mm-hmm. Okay?
Which means the rate of the southbound is too.
Right. So what they wanted us to find was the rate. Find the rate. So the rate of the northbound is 44. The rate of the northbound is 44, so that means that the rate of the southbound is 44 kilometers. So the answer would be 44 kilometers per hour for that problem. All right, let's go and watch this next one. And I do not want you to try to move on or turn this off because each one of them not really gets harder, but they are hard. So we need as much practice as we can get. So listen to this next one. This is 94.2. All right, a train starts from Toledo at 11 a.m. and heads for Mackinac. Okay, so we have Toledo and Mackinac. Toledo to Mackinac. Okay, and so a train starts in Toledo and heads toward Mackinac. Okay, and he starts at 11 a.m. I'm just writing down some key information. Okay, and heads towards Mackinac, which is 332 kilometers away. So from here to here is 332, and again they're using kilometers. Kilometers away. At the same time, another train leaves Mackinac and heads for Toledo. So here we go, we have another train going from here to here. So I'm going to name this one Train 1 and this one Train 2. Okay, one's going from Mackinac to Toledo and the other one's going from Toledo to Mackinac. Now, it says at the same time, so at 11 a.m., same time, a train leaves Mackinac and heads for Toledo at 65 miles per hour. So I'm just going to write down key information for just a second. Train 2 is going 65 miles per hour. Okay? Let's do this. I'm going to write train 1 because I'm going to get them mixed up with the T, train, and time.
Yeah.
So let's just put train 1 and train 2. Okay, and then this is train 2. Let's write it over here. Train 2 is going, this is his rate, so the rate of 2 is, rate is a 60, remember, miles per hour. So we know that train 2 is going 65 miles per hour. Okay, that's some key information that we needed to know. Okay, then it says, heads for Toledo at 65 miles per hour. If the trains meet, so one's going from here to here and one's going from here to here, they meet at 1 p.m. They collide, kind of like, at 1 p.m. Right? They meet at 1 p.m. What is the rate of the first train? We're wanting to know the rate of train 1. That's what we're trying to find out. Now, so again, we want to go D, T, R. All right, let's find our distance. All right. The distance between train 1 and train 2, do you get that it is the distance of train 1 plus the distance of train 2 equals 332, right?
Yep.
Okay, which is really saying because distance equals rate times time, then the distance of the first train equals the rate of the first train times the time of the first train. So the D1 is the rate of the first train times the time of the first train. Plus, and then this would be 2.
The rate of the second.
And it would be the same thing. The distance of the second train would be the rate of the second train times the time of the second train, which equals 332. Good?
Yep.
All right. Now, do we know time? Well, we know that they left at 11 and they collided at 1. How many hours is that?
2.
Right, 2. So the time of train 1 is 2, and train 2, the time of train 2 is 2. Yep. So they're the same. So we also know that T1 equals T2. Just a side note. I don't know which one we're going to use yet, so we'll see. And then R, what are the rates? We know that train 2, which is the rate of train 2, equals 65 miles per hour. And we don't know rate of train 1. That's actually what we're trying to figure out. Okay, so now, again, you take this one, this big one up here, and that's what you use to convert everything. So I'm going to put R1 times T1 plus R2 times T2 equals 332. All right, do we know R1? No. Do we know T1? Yes, 2 times 2. Do we know R2? Yes, 65. Do we know T2? Yes, 2. And this is times. Okay? And now, all we have to do is figure out what R1 is. So let's do that. So 65 times 2 is 130 plus 2R1. I just rewrote that. Equals 332. Then I'm going to get this on one side, and then this plus 130 over on the other side, so it minuses it, which ends up giving us, oh boy, 102. 202. Yeah. And then this is 2R1, so this says 2 times R1, so we're just trying to get R1 by itself. So this times 2 becomes divided by 2 when you cross the equal, and R1 equals 101. So, 101 what? Well, it's a rate, and we know that we're doing miles per hour on this one, so it's 101 miles per hour. So the rate of the first train was 101 miles per hour. Got how we did that? Pretty cool?
Yep.
All right, this next one I'm not going to finish out. We're just going to set up. So help me to set it up. And this one I kind of want you to do on your paper as we're reading it. Okay, let's try to figure out what we're doing first. So I'm just going to read the whole thing first. The ships were 400 miles apart at midnight and were headed directly toward each other. If they collided at 8 a.m., find the speed of both ships if one was 20 miles an hour faster than the other one. Okay, so again, we know that there's two ships. So I'm going to name it Ship 1 and Ship 2. And the ships were 400 miles apart at midnight. So they're apart, and then they collide at 8 a.m. So I'm going to show this. This one's going this way. This one's going this way, and they collide at 8 a.m. Do you remember what time they left? 12, midnight. 12 a.m. Okay. Now, and it says the ships were 400 miles apart at midnight.
Yeah. That's going to be trying to find the right.
Very good. Now, let's see. So we're going to write down D, T, and R and figure out if we can figure out anything. Okay, so we can do distance first. We know that the distance of
The first ship.
ship 1 plus the distance of ship 2 equals 400 miles. Okay, this one's going to be miles per hour again. Okay, and now again, because we know that distance equals rate times time, distance, or the distance of train 1 would be the rate of train 1 times the time of train 1. Plus
The rate of train
again, the distance of train 2 would become the rate of train 2 times the time of train 2, which equals 400 miles. Okay, that's our equation that we're going to insert stuff in. But let's figure out if we can figure out time. Do I know the time? How much time? How many hours has passed?
8 hours.
12 to 8 is 8 hours. So let's do time.
We can just do
Time of ship 1 is 8, and time of ship 2 is 8, which really means that time 1 equals time 2. I think we're probably going to use these, but that's a good thing to make up. Okay, and do we know the rate? Did it tell anything about the rate? If they collided at 8 a.m., find the speed of both ships if one was 20 miles an hour faster. So, the rate of one of them, we don't know which one, equals the rate of the other one plus 20, because one of them was 20 miles an hour faster. It didn't tell us which one. It just said one of them. So I could have put R2 and R1 here. It just said one of the ships. So the rate of one of the ships plus 20 was, it was 20 miles an hour faster. So I'm just going to leave it like that. That's fine. Okay, so here's what it said. Find the speed of both ships if one was 20 miles an hour faster than the other one. 20 miles an hour faster.
Yep.
Okay, and what the question they're wanting us to find is find the speed of both ships, which is the rate. Rate is speed. So what we're trying to do is find the rate of both ships. Both ships. Okay, now let's use this equation, and I'm going to leave it right here and just insert everything in right here. Do we know what R1 is? No. Do we know what T1 is? Yes, 8. Let's times it. Okay, do we know what R2 is? Yeah.
It's
R2 is that, so
R1 plus 20.
R1 plus 20. And then it says times T2. Do we know what T2 is? Yes, 8. 8. I'm going to put this in parentheses because the 8 is supposed to be multiplied by all of this. Okay, and equals that. We're done. Now, I'm going to go and move this so that I can work this. Okay, so this becomes 8R1 plus, and let's go and do this, 8R1 plus 8 times 2, 160 equals 400 miles. I'm going to add my like terms. 8 plus 8 is 16. 16 of the rate of the first train. And I'm going to move this plus 160 across. Well, like I said, I wasn't going to do this, and now I'm doing it. Okay, I'm doing it. Okay, and so this is going to give us, what, 240? So 16 RI equals
R1.
240, R1, sorry, thank you. And then, so we're trying to get R1 by itself, so this times 16 becomes divided by 16. And R1 equals, I'm gonna cheat, 35? Or maybe it's 15. Let's do it, I don't know, 240, 16, it's gonna be 15. Okay, so R1 is 15, okay? So, if R1 is 15, then what was the rate of the second train? The second train is 15 plus 20, which is 35. So all they asked was, what is the rate of the trains? So you say the rate of one of them is 15 and the rate of one of them was 35.
Okay.
So, and since it's a rate, and we're doing miles, then it's miles per hour. Miles per hour. Got it? That's lesson 94.